Love 1220. I'll go ahead and get started. So I'm Matt Larson from the HDF Group. I'll be talking about some recent changes to test file generation, how the scripts are set up, how it all works internally, and then some changes that are coming soon. Here's an overview of the topics I'll be covering. First, I'll just give a brief overview of tools, the generators, test files, how all that's set up just for context. Then I'll go into the recent changes to the tool test file generators, how those have been brought up to speed, and the recent changes to how they're laid out. I'll go into output masking for generated test files, what that means and what's been changed there and why. And then lastly, I'll go over some new features that are coming soon for test cases for vault connectors. All right, so just as some context, many HDF5 files use pre-existing files that are stored in the repo. And the reason that we do this, instead of just generating every single test file on the fly, is that it serves as a source of external ground truth. So that certain kinds of, potential bugs within the library don't erroneously think they're making good files, but they're actually producing something messed up, and then they don't check it right. That's just kind of a sanity check. And most tests for the HDF5 tools, like HDF copy and HDF dump, also follow this format. They have their own set of test files that already exist in the repo and have been pre-generated and haven't changed in a while. But in addition to those pre-existing test files, the tools also have these generator scripts, which can generate the same test files on the fly. So for example, H5 copy has an H5 copy gen test script, which will generate the list of like 20 or 30 test files that H5 copy tests expect to find, with all the internal groups and data sets and whatnot that those tests expect. So we have kind of these two different sets of test files that can be used, the ones that are pre-generated and the ones that are generated on the fly at test time. Now, as things stood initially a couple months ago, those generators were pretty out of date. They didn't have all the test files that were expected. Even when they did have files, there were some internal conflicts, like data types that would be big ending on some systems, little ending on other ones. Some like fields in data types weren't generated quite right. And on top of all that, these generators weren't built in CI. They were stuck behind a build option, which defaulted to off. And so they weren't even really being tested. So those have all been now brought up to speed. The missing files have been added back in, file conflicts have been made consistent, so now generated files will match the ones that are just in the repo by default. And the build option has actually been removed entirely. So now these generator scripts are created by default. The initial reason for putting that away behind an option in the first place was that when doing this with auto tools, that imposed some additional requirements with static linking. But since auto tools has been removed, we no longer have to worry about that. So this is a very slight simplification of the build, which we can call, I think, a win for removing auto tools. Now, integrating the generator scripts and removing duplication. So previously, each tool had its own dedicated generator, like H5 copy gen test. And in cases where there were identical files that multiple different tools wanted to use, that was kind of handled haphazardly. For example, we had a test file with attributes that contained references, and H5 dump and H5 diff both wanted to use this. H5 diff would just go in and grab it and copy it from H5 dump's isolated folder file. And there were, a couple dozen odd cases of this, and there wasn't really any consistency in how it was done. If you want to figure out whether or not a file was shared or how it was actually shared, that was a huge pain. Since then, we've merged the generator scripts into a single shared executable, H5 gen test, which pulls the definitions for individual test file generation functions from specific tool headers. So now if there's some test file that multiple tools want, because that function is shared to generate that file, they can each independently generate their own identical copy and do whatever they need to do to it. Here you can see a little snippet of the help display for the H5 gen test script. You can generate all the test files or just the ones for whichever particular tools you're interested in testing. All right, now we'll go on to output masking. So how most of the tool testing actually works is that there is a reference file stored in the tool test files. Something like when we call H5 dump on this file after the test, we should see these groups and this data set with this name containing this data of this data type. And for the most part, that works fine. But there are a couple edge cases where not every field is guaranteed to be 100% consistent. One thing is that H5 dump assigns these numbers to anonymous data types. And the way that's done isn't consistent in a publicly accessible way. So certain internal changes could change that, or the active vol connector could change that. Another thing is the exact object offset of certain objects within the file isn't always 100% consistent. And so there can be issues where seemingly nothing has changed and everything is still valid, but you're seeing test failures because some object is, a few bytes off from where it was when the reference file was generated. And the solution to that is to just mask out any information which is not guaranteed to be exactly, character for character the same. So instead of comparing this reference, which says, 2040 bytes, they'll just say offset some number of bytes. So as long as the whole structure of the output is the same, the object exists, it has some offset, that comparison will resolve true, and the test will see that it's fine. So some changes have been made to this to, kind of modernize it and bring it up to date for the later implementation of vol tests. One was support for applying multiple masks in a row. Previously, each reference file could only have a single mask applied, and now we can support multiple. And with that, now we can apply masks for multiple things. One is for, those data type numbers I mentioned. Another is exact addresses that aren't guaranteed to be the same, and so on. Another change is that these masks, these filters, are applied in memory. The actual reference files on the system in the repo aren't changed. And that's useful because, if we make some change and now suddenly all the addresses in the file have changed wildly, that might be fine, but if that was an accident, we want to know what caused it and if that has any unintentional side effects. So doing this in memory just lets us see the internals and check if anything unusual is happening. And lastly, there was a bunch of internal CMA cleanup on how this is done. Removing duplication across different implementations of similar work, cleaning up option to scripts, and so on. But none of that is externally visible. And now what actually motivated most of these changes, what kind of spurred the initial investigation into how all this tool testing is done, is implementing tool tests for vol connectors. So what this will be is that when the user loads their connector at build time and sets it up, when tool tests are generated, the library will automatically build and generate vol counterparts for each of the tool tests. So if you have, test 1, it will generate a counterpart of test 1 for each loaded vol connector. And additionally, it will also generate the necessary files, or files in quotes, for each of those tests. So if you have some connector that translates the file format to like objects in an object store, it will run the generator script with your connector active. And so it will generate the necessary files or the counterparts for those files in the object store by going through each individual create, dataset create, write operation. Now, it will be up to the user to determine which tests are appropriate to run, what actually makes sense for the current volt connector. Because, for example, if your connector doesn't support attributes, that's going to rule out a lot of these tests. So it won't make sense to run them in that case. So that will still be something that individual users or connector developers have to worry about. All right. Thanks for listening. Any questions or comments about what I went over?
Or any general HDF5 questions? Probably not with the group we have here today.
About the experts.
Yeah. All right. Thank you, Matt, for stepping in for John and sharing that with us. And we'll put this recording up on YouTube.
All right. Thanks for having everyone.
Thanks, everyone. Bye-bye.